Okay, so today we're going to talk about correlations, and we're going to start with two different types of correlation. So the first one is bivariate, which is a correlation between two variables, and this is what we're going to normally think of whenever we think about correlations, like the correlation between age and weight, or weight and calorie intake, or something like that, just to see the relationship between those two variables. And obviously, the assumptions that are listed right here would need to be true in order for this correlation to be accurate and correct, or the prediction of the correlation. So you're going to have a correlation coefficient from this, especially if you use the Pearson's test that's talking about right here. Another example of a correlation coefficient is a biserial one, and this is going to be used for a bivariate correlation, and that is whenever there are two variables are dichotomous, and one of them is dichotomous, and so the category, there would need to be two different categories, but just only two, not more than two, for this relationship. And so one of the variables would need to either be like male or female, or pregnant, non-pregnant, something like that, so that it would be a dichotomous relationship there. And then the other type of correlation that I'm going to talk about is partial. And I'm going to scroll over to that screen really quick, if that's okay. Okay, so partial correlation is going to be quantify the relationship between two variables while controlling the effect of one or more variables. So this is going to be making sure the third variable has to be constant in this, because that's the one that you're going to be controlling for the effect of. And so you're going to control for the effects of the third variable that it has on both of the other two variables. So they're going to want to make sure there's a relationship between all three of them, and that is constant as well. So basically, you're trying to control the impact of that third variable has on the other two variables. And then the semi-partial correlation is going to be quantify the relationship between two variables while accounting for the effects of the third variable, but only on one in the original correlation. So this is going to be like if there's three variables, one of the variables would impact the other one more, or have a relationship more, and so then you would control for that one instead of if you were looking at the other two variables, their relationship. So, for example, if I use BMI, calorie intake, and heart rate, the BMI and calorie intake are obviously more related than the BMI and the heart rate, or the calorie intake and heart rate. And so if I wanted to control for calorie intake and I wanted to see the relationship between the BMI and heart rate, I would use the semi-partial correlation. So hopefully that makes sense.